Well, I want to thank everybody for joining us, and I especially want to thank David Wood of the for joining us. He's with the Chesapeake Stormwater Network, and David will be presenting for a large portion of today's webinar. We're going to talk about modeling stream restoration and show you how to do that in CAST. This is part of our regular monthly webinar series. So for those of you tuning in every month, this is going to be focusing in on the streams. Some of you may not have joined some of our monthly webinars, and that's fine. But we do expect there to be some general familiarity with CAST, which is the Chesapeake Bay Program's Phase 6 watershed model. And we're going to talk about the changes in the stream restoration protocols. We're going to show you how to enter those BMPs and see the BMP effects in CAST. Before I turn the program over to David, I wanted to spend just a moment in the beginning to give you a refresher on how selecting stream restoration BMPs looks in CAST. Today we're going to be looking at a number of different things. We're going to understand those restoration BMPs and how they've evolved. They started off years ago with just one stream restoration BMP that had a set default, and there have been protocols and other changes, and David's going to go over what the current status of those are. I'll show you how to enter the BMPs in CAST. This is the version of CAST that is the Phase 6 CAST 2017 version. It'll work the same way in the next version of CAST, but is different from what we used several years ago. And I'll show you how the calculation of nitrogen, phosphorus, and sediment works, and where you can get those loads and figure out what the load reductions were for streams and how that affects various sectors. So I'll show you how to find that information when you run your scenarios in CAST. So first thing is when you're in CAST, and I've got this slide, but I think what I'm going to do is just go straight to CAST and show you. When you're in CAST on the home page, you're going to log in, and I've already logged in. You'll go to the scenarios page, and you'll take a scenario. Either you'll add a new scenario, and we've been through this in other webinars, or you can just use an existing scenario, which is what I'm going to do. I've got this example with a Cabin John baseline and Cabin John 2019 BMPs that I'm going to use. When you're in this scenario, I've already added a number of BMPs or copied them in. You'll see these in these tabs. You're going to want to do your streams under natural because we classify streams as a natural load source or land use within the model. So streams, wetlands, forests, those are all in the natural classification. So even if you may be doing a stream restoration in an urban area, you're not going to find that underdeveloped. If you're doing it in an agricultural area, you won't find that BMP under agriculture. It'll be under natural. So you would just click Add BMP like you're adding for any scenario. And when you see the drop down for a BMP, you'll select Stream Restoration. And then you'll have the secondary BMP options. And those will give you the option of doing the protocol or the regular one. If I pick the regular one, I get the units of feet, and I would just enter how many feet for my project. And if I pick the protocol, then there's a whole lot more on the screen. And you can see that I have the option of entering pounds in addition to feet. So I would enter however many feet there it is for this project. And then I would enter my protocol 1, nitrogen, phosphorus, or sediment, my protocol 2, in-stream denitrification pounds for nitrogen, my protocol 3, nitrogen, phosphorus, or sediment. Either way, you have to enter the feet, but what is calculated are the pounds. So I would just add in that information. I'm not going to do that now, but I did want to just kind of orient you on CAST that, you know, this is where you go in your scenario to add that, and those are the options that are available in the scenario. So that's where you go. And I'm going to turn it over to David at this point. David, do you want to, let me stop sharing my screen and you can start sharing your screen.
Great.
David's going to give us a lot more background.
All right, so just give me 1 second to get the slides up here.
Yep.
All right, can you see and hear all right?
It looks great.
Okay, excellent. So thanks, Olivia. As Olivia just mentioned, I am going to try to orient you a little bit to the stream restoration BMP protocols. For those of you who are joining because you are CSN network members, you may have heard some of this before. We've been trying to keep folks up to date because the stream restoration BMP has had quite a long history, even though it's only been 5 or 6 years since the original expert panel report came out. And we are actually in the process of revisiting those protocols now. So I'm going to tell you a little bit about the original protocols, sort of the intent behind it, so you can kind of get your bearings, and then give you some updates as far as the changes that have been rolled out over the last about year and a half that we've been working at the Chesapeake Stormwater Network. So as far as the original stream restoration expert panel report, it was approved back in 2013. At that point in time, the practitioner community, local government, states wanted to do a test drive of the different protocols to calculate the nutrient and sediment reductions from stream restoration practices. So they took it for about 6 months, tried it out, made a few tweaks and changes to try to make things a little simpler, a little bit easier to use, and then it was re-released in 2014. In 2017, there were some changes to the way that sediment delivery was simulated in CAST, as well as just a few other changes to the modeling tools of the Bay program that we needed to keep up with. And so we put together at the Urban Stormwater Work Group a frequently asked questions document with the Center for Watershed Protection in early 2018. What that did was basically lead to a lot more questions than it did just straightforward answers. And so in the summer of 2018, we kicked off an effort to form 5 different groups to go back and revisit each of the stream restoration protocols. And we have been working on that ever since. So the original protocols had a couple of really important elements to them. Basically, they had 3 different protocols that were intended to address the different pollutant removal pathways that can be achieved from stream restoration practices. And that's prevented sediment erosion from the banks, the in-stream denitrification, and then the trapping and settling of sediment and nutrient particles in the floodplain when you reconnect the stream to its floodplain. So the expert panel also laid out a series of qualifying conditions to make sure folks understood which practices were eligible for crediting under the Chesapeake Bay TMDL. And then they put a lot of emphasis as well on the importance of providing functional uplift and doing comprehensive restoration practices rather than going in and just working within the stream because it was maybe cost effective or sort of a one-stop shop. You need to be working towards achieving better habitat, better riparian areas, integrating upland BMP, stormwater retrofits, and things like that with your stream restoration projects so that you can maximize the resilience of those practices as well in the long run, as long as that's available. And I'll talk for a minute quickly about the different design approaches that are used for stream restoration, because it's a pretty easy way to, as we've been saying at CSN, to start a bar fight is, coming in with your different views on how to do stream restoration the right way. So the panel tried to be pretty agnostic about those approaches. So as I mentioned, these are the different protocols. I'm going to focus on 1, 2, and 3. The group also used at the time, they called it Protocol 4 for dry channel regenerative stormwater conveyance practices. And those were basically credited as a stormwater retrofit as opposed to a stream restoration. So I'm not going to talk a lot about that today. So Protocol 1, the prevented sediment protocol, used a basic, multiple step approach here. This is the one that is the most popular protocol, or at least it's used and reported the most frequently. Generally, the largest nutrient and sediment reductions come from this protocol. Essentially, there are a number of different methods that you can use to calculate the annual stream bank erosion rate for an existing degraded or incised channel. You take that erosion rate, you can multiply it by the soil nutrient concentration of the soils, and then there was this 50% efficiency factor that basically said, you're estimating what your erosion rate is under the degraded condition, you restore your channel, but it's probably not going to eliminate 100% of all of those nutrients and sediments. These are dynamic systems. There's always going to be some movement in those systems. So to be conservative, as all expert panels are charged with being, they used a default 50% efficiency based on that erosion rate. The second protocol was for denitrification during base flow conditions. The panel essentially used this concept of a hyporheic box where you're getting frequent exchange between your surface water within the stream channel and that near surface groundwater, that hyporheic zone that has the soil saturation and the anoxic conditions and things like that that you need for denitrification. And so they determined that the way to define those boundaries were you'd have this area that was, or this volume that goes 5 feet beneath the bottom of the channel and then extends 5 feet on either side of the stream width. So that is sort of the area along the restored stream where you're getting denitrification. So you have your volume, you multiply it by the bulk density of the soil within that box, and then you multiply it by a unit denitrification rate. And so that denitrification rate by your soil volume is how you get to your total nitrogen reduced from protocol 2. And protocol 3 was probably the most complicated of the protocols. It's for floodplain reconnection. Basically, you define the area of your floodplain based on hydrologic and hydraulic modeling typically. That tells you where you're getting water out onto the floodplain during storm events. The original panel used an approach to determine what volume of water was accessing the floodplain for treatment using, we call them upstream methods, where basically you use rainfall and runoff models to determine how much the water elevation is changing and accessing that floodplain during different size storm events to get that total volume diverted onto the floodplain. And then you would multiply it by a treatment efficiency that's based on wetland nutrient and sediment removal. So that's the real, down and dirty basics of that. And I'll talk a little bit about some of the more specific changes in our review, but that should hopefully orient you to the 3 different protocols and sort of how they're used. All 3 of those protocols are additive. So if you do have a project that achieves floodplain reconnection, promotes denitrification within the hyporheic zone, and prevents sediment erosion, you can add those nutrient and sediment reductions together. There are a couple of different design approaches, as I alluded to earlier. These are natural channel design, which was really most common back when the original expert panel was formed. Recently, we've seen a shift towards more legacy sediment removal projects and regenerative stormwater conveyance. RSC projects are really popular in urban areas because we have highly constrained sites, a lot of steeper slopes, things like that. Legacy sediment removal works well when you have a really wide floodplain area to work with, but we're seeing more and more application of those approaches as folks tend to shift in the last couple of years towards really realizing how important and significant that floodplain reconnection and the hyporheic exchange is, whereas I think past approaches were a little bit more zeroed in on that prevented sediment. And I just want to take a second to talk about the qualifying conditions that the original panel had, because I think it's often overlooked when folks are assessing their different projects to report for crediting. And some of these have been upgraded as well, but essentially the original panel said that these stream restoration projects do need to be comprehensive projects. So something that's implemented just for public infrastructure protection. So if you're throwing riprap down the side of a bank to protect the sewer line or something like that, that wouldn't qualify for credit. It can be part of a larger project that has nutrient and sediment restoration, functional uplift as the larger goal, but it shouldn't be the sole reason that a stream restoration is implemented. The project should be longer than 100 feet in length. It was designed to prevent things like the use of, just drop structures and things like that to protect a very short segment. Also those, like I said, those infrastructure protection type projects. Functional uplift was a huge component of that. And again, that's, making sure that the project is addressing biological and habitat goals in addition to the nutrient and sediment goals of the project. A few environmental considerations were listed as well, in addition to meeting any permit requirements by the appropriate state, local, or federal permitting authority. Focusing projects on areas that have the most severe impairments was a major point of emphasis by the panel. Areas that are actively eroding and degrading to prevent folks going in and messing with otherwise pretty well-functioning streams in order to get nutrient sediment reductions. Also paying attention to riparian vegetation impacts and things like that, having plans in place for those. So just wanted to mention that those are all being carried forward in the future reviews. So as far as revisiting the protocol, there was a big need for this because since the report came out back in 2014, there have been hundreds of miles of stream restoration implemented as well as in the pipeline. It's a pretty cost-effective BMP on a $1 per pound reduced basis. So, while the projects are expensive, they're an attractive option for communities for meeting their nutrient sediment goals. But it is a rapidly evolving market as the private sector kind of got a hold of these protocols and realized that there was an opportunity. There were a lot of questions that came up about proper application, trying to standardize how they're being applied around the watershed and whatnot. So this just goes to show how much the practice has really taken off. As of 2018, progress reporting across the Chesapeake Bay watershed, there were just under about 300 miles of stream restoration that had been implemented. But taking a look at the phase 3 watershed implementation plans, there are over 900 or just about 900 miles planned between now and 2025. So there was a need to kind of get this guidance out there as soon as possible so that it could be incorporated. And then I mentioned too, as the industry evolved, it was really recognized how important site level data collection was in getting appropriate and proper crediting estimates for nutrient sediment reductions, because using a default rate doesn't account for the fact that a stream with a 2-foot bank height is very different than a stream with a 15-foot bank height in terms of the erosion, the prevented sediment. There's also a lot of really site-specific, and even within a site, differences, between soil textures, bulk densities, soil nutrient concentrations, and things like that make a really big difference when you're adding up your nutrient sediment reductions. So these are the 5 teams that we put together. The first group was better guidance for verifying stream restoration practices that are implemented for Chesapeake Bay TMDL crediting. These stream restoration practices are a little bit more vulnerable to things like climate change events and whatnot because they are inline practices. So they have to be inspected every 5 years as opposed to most stormwater practices, which are every 10 years. There was another group that looked at outfall and gully stabilization practices specifically and added another option for Protocol 1 to address those types of practices. Group 3 revisited the prevented sediment protocol. Group 4 looked at protocols 2 and 3 for floodplain reconnection practices. And then a 5th team was sort of formed on the fly as a branch off of Group 4 to provide guidance that was specifically tailored for legacy sediment removal projects, since there are some pretty important differences in definitions, qualifying conditions, and things like that for those practices. This was a really large effort. This is our list of experts, and I won't go through and name every one. If any of you are on the line, thank you again for all of your hard work on this. But across those 5 groups, we had well over 60 participants that were actually group members. And then we probably had 15 or 20 folks, if not more, that were involved throughout the effort in just providing review and feedback. So the first memo on the verification guidance was approved back in June of 2019. The link where you can find it is available here, and we will make these slides available to you so you can link to it directly if you're looking for it. But the basic idea was that they wanted to come up with a pretty straightforward verification system where you can go out and do a field assessment with staff that don't have to be engineers. They can be just trained to look for certain key visual indicators, so you can kind of walk the length of a stream reach once to kind of identify specific indicators, and then on your walk back to your truck or vehicle, you can take any measurements that are needed. So they provided a criteria for each protocol a couple of visual indicators. So for protocol 1, things like bank undercutting, you know, an incising bed, flanking of downstream structures, things like that. And then they tied them to specific management actions. You know, whether the project, based on those indicators, how much of the reach was, you know, functioning, showing major compromise, and then based on that, you can make a decision about, you know, either going in and doing, we call them forensic investigations, where you're really finding what the root of the problem is, or you can pass it and renew that credit. There is some wiggle room there as well for sort of best professional judgment around the edges, because of course every stream site is different, so they didn't want to have really hard and fast rules there. So this is what that can look like in terms of visual indicators. You might see something like in the top left, where you have some minor head cut migration that might be a minor issue. Structure flanking on the right-hand side, on the upper side. The bottom right is sort of a worst case scenario. Obviously you had some sort of a bank protection in place there, and the stream chose not to follow the guidance. And so that would obviously be a project failure. The second group for outfall and gully stabilization, this report was approved in October of 2019. Again, the link is there. The primary purpose here was to address a specific type of site condition at these outfalls, where you have severe vertical incision that's usually caused by uncontrolled upstream runoff. So again, that gets to the point of making sure you're using comprehensive restoration approaches. You're also looking at those upland sources, so you can kind of address the source of the problem as well as the symptoms here. But you get these really tremendous gullies, and the feeling was by our experts that the original protocol 1 was not great for addressing this vertical incision. It's really good at capturing the lateral movement of the banks, but where you have these vertical slopes and you get this down cutting, there was a need for another option to calculate the prevented sediment. So the basic approach, without going into too much detail, you can check out the report for the specifics, but you have your existing surface area. You can run some calculations and perform some modeling to determine what the future stable surface is for that channel, whether there's a baseline control or something like that, where the site is no longer expected to be eroding. And then you sort of calculate the difference in material there, and that's what your prevented sediment load is going to be. So this one's a little bit more complex, requires a little bit more engineering, but does provide an option for folks who are looking for that. The third group for prevented sediment, Protocol 1, was approved in February of 2020. Again, the link is there. The recommendations for this report, revisiting the prevented sediment protocol, sort of breaks down into 4 large sets of recommendations. The first was to provide a clear definition of bank armoring. So if you remember, there was a qualifying condition for the original expert panel report. The projects designed to protect public infrastructure by bank armoring would not be eligible for credit, but they didn't really elaborate on what constituted bank armoring. So we went back and revisited that, shored that up a little bit, put more of an emphasis on that site-specific data collection that I was talking about earlier, added more guidance for the different monitoring and modeling approaches that can be used to estimate the bank erosion rates, and then provided some recommended ways of calibrating the bank's assessment, which is one of the techniques that is often used to get bank erosion rate estimates, but there's some subjectivity involved, as there is with a number of the approaches, but it's probably the most common and was originally sort of recommended as an approach by the original expert panel, so they wanted to address that specifically. So these are the armoring definitions, the armoring categories for stream restoration. They broke it into 3 categories. The first is non-creditable armoring. So things like concrete walls, gabion, dumped riprap that aren't really restoration approaches. They are infrastructure protection approaches. So if your stream restoration project includes one of those approaches, you would have to subtract out the length of the restoration that uses those from your total credit. And we'll walk through an example before we wrap up. Creditable with limits are some harder practices, but they are part of comprehensive approaches. They usually provide interstitial spacing for habitat. Those you can use on up to 30% of your banks before you start getting dinged. And then creditable are sort of your softer, more natural bank protection approaches, and those are fully creditable. I'm going to start moving a little bit quickly because I'm looking at the time and I'm running a little bit up against it. But we also wanted to address the default rates. There were defaults throughout the report to try to make things easier, but the sense of, again, the experts was that they were being overutilized. There were nutrient concentration default rates. There was a bulk density example that wasn't actually ever intended to be a default, but was being used as a default. And then the linear foot nutrient and sediment default rates in the report were being used in lieu of the protocols. And that was never something that the original expert panel felt comfortable with. And so the experts wanted to come out and reinforce that as well. So they recommended methods for site-specific monitoring of bulk density and nutrient concentration that are now required as part of this method. There are field and lab methods included, and again, stronger use on the need to use the protocols to calculate your reductions. They also have more information on monitoring guidance. So as I mentioned, the bank's approach was sort of spelled out explicitly, and then other methods were referenced but not really expanded upon. So this report goes in, talks more specifically about bank pin monitoring, using permanent cross sections, using LiDAR and DEM differencing approaches, if that's what you're using. You can also go in and get more information about that 50% conservative efficiency factor that I talked about a while ago. You can adjust that if you go in and do site-specific monitoring to actually measure what your nutrient sediment reductions are. And so they tell you how long you have to monitor, what type of monitoring needs to be done, and you can actually go back and re-report those new numbers to get the credit backdated for you. Now, the last report is Group 4, Protocols 2 and 3. I'm going to be pretty brief on this one. This report is going to be coming out for public comment either on Friday or on Monday of next week. So we're really close to being done here, but I'm not going to spend too much time on it because the report is just being finalized right now. So there will be a public comment period. But the basic approach here is they're looking at some tweaks to the definition of that hypereic box. I think it's looking like they're moving towards an aerial hypereic exchange zone. So as opposed to calculating that volume beneath your stream channel, you're going to be able to expand that zone further laterally into the floodplain, but it's not going to be as deep of an area. They are also revising the way in which you calculate how much volume of water is diverted into the floodplain as well, to try to capture the flows that are getting out under smaller storm events, which the rainfall runoff models don't do a great job of. So again, sort of updating that expanded hypereic zone, updating the denitrification rate itself based on the most recent science and literature review that they conducted. They are also incorporating the new wetland expert panel removal rates, since the old efficiencies for Protocol 3 were based on the old wetland expert panel. And then they have a lot of information in there on best practices for avoiding unintended consequences for stream restoration. All right, so I just want to wrap up with a quick example. I'm going to use Protocol 1 as an example here, since that is the finished report. As I mentioned, you would be able to add on the credits for the other protocols, but what I'll say is just be on the lookout. Once that report is finalized, we will have a full webinar at CSN going through those recommendations in detail and have some examples as well. So for this example, let's say, at the very start, your project has to meet all the qualifying conditions. So let's say we've gone through, done a thorough review of those, and we meet the qualifying conditions. So you have a 500-foot length of stream, which is 1,000 feet of total bank, right? You've got 500 feet of bank on each side of the stream channel. For this approach, we had a natural channel design. So you've got a single meandering channel, got some riffle grade control with some floodplain reconnection. So you would be eligible for protocols 2 and 3 here. But again, we're going to focus on protocol 1. Now you do have, while this practice is meeting all those qualifying conditions, you're looking at functional uplift, you're looking at your nutrient and sediment reductions, you're looking at habitat and biological factors. So you're doing a comprehensive approach, but you do have a sewer line that runs adjacent to about 100 feet of the right bank. And so you had to bring in, or your designer brought in some harder gabion baskets to protect just that 100-foot stretch of the project. So starting with the erosion rate calculations, there's this equation that is used where essentially you use the bulk density of the soil, your bank erosion rate, and your eroding bank area to come up with your total sediment load here. So in this example, again, because we have to do the bulk density measurements on the site, for this example, you collect 5 samples along the reach, so about every 200 feet, including samples from each soil horizon. These are the recommendations, and you come up with a bulk density of 75 pounds per cubic foot. You use bank pin measurements here for this project, and you found that your erosion rate was 2.4 feet per year. And then your eroding bank area, again, you had, remember, 1,000 feet of bank, but 100 feet of that was gabion baskets. And so you have to subtract out that 100 feet from your project length. So you only have 900 feet of eroding bank area under this example. And when you run that through the equation, it's 81 tons per year. Now this is a little oversimplified because I'm treating the rates as the same across the entire reach. Generally, if you have a contractor or someone doing this project, they're probably breaking this down. You're going to have different erosion rates on different meander bends. You know, the outer bend of the meander is going to be eroding much faster, and so they're going to be focusing on those areas. And that's why you sort of have, it's the sum of these different segments. But for simplicity, this is how we're going to do it for this calculation. Then you go to the soil nutrient concentration. So you have your sediment load. Again, you're doing your site monitoring for soil nutrient concentrations. So again, probably using the same sites that you took your bulk density samples. This is a best professional judgment call here, but we'll say again, 5 samples every 200 feet. And you find that you have 0.5 pound of phosphorus per ton of total sediment and 1.7 pounds of nitrogen per ton of sediment. And those are your soil nutrient concentrations. So you multiply those by your sediment load, and you get your 40.5 pounds per year of phosphorus and 137 pounds of nitrogen. And then we get to the efficiency factor. And so you have your 2 options here. You can take the default rate. And so you're multiplying those numbers that you calculated by 50%. So that comes out to 81,000 pounds of sediment, just over 20 pounds of phosphorus, and about 69 pounds of nitrogen. A big change, and I think Olivia might touch on it as well, but a big change from the last model to this model, you no longer multiply those numbers by a sediment delivery factor before you report it for credit. CAST handles that for you within the model. So you are still experiencing sediment delivery reductions sort of as it makes its way from your project site to the bay, but you don't have to do that step in the calculation. So these would be the pounds that you would report for credit. Alternatively, you can report that now, and then you can decide to go in and do your site-specific monitoring, long-term monitoring of your restoration. And so the recommendation of the panel, you would have to have 3 years of post-restoration monitoring using the same approach that you used in your pre-restoration monitoring, so bank pins in this case. You find that your new bank erosion rate is only 0.4 of a foot per year. So you go out and you kind of calculate that difference, and your efficiency now, instead of 50%, it turns out is 83%. So you can go back and re-report your new values for sediment, phosphorus, and nitrogen, which you can see there on the screen. And then if you report the implementation date with that new data, it'll replace your original numbers and you'll receive that credit backdated to the date of implementation. All right, so that was a lot of information to throw at you pretty quickly, but I will stop there and see if there are any questions. Olivia, I haven't been able to keep an eye on the chat box, but.
There's nothing in the chat box, David. That was really helpful, you know, and hearing the status of these groups and teams for updating protocol 1, 2, and 3. So thank you for that. I want to walk through an example of using the protocol 1 as you outlined and show people how that works in CAST. Before I switch to that, there is a question that showed up in the chat box, which is, are revisions to protocols 2 and 3 coming out this week, or is it just a revision to protocol 2?
It's the revisions to protocol 2 and 3. So like I said, I'm hoping that the the draft will be posted either Friday afternoon or early on Monday, and they'll be presented to the Urban Stormwater Work Group on Tuesday, opening up a partnership comment period.
Yeah, okay. And I see another question about how this is integrated into CAST. I'm going to show you that in a minute. Are there any other questions before we switch over to doing this in CAST?
I see the
David,
question
where are
about
the yeah.
Yes. Yeah, the revisions to Protocol 1, they are on the Chesapeake Stormwater Network website, but I also had the link to the recommendations in the slide deck today. So if you want to go and download it directly, you can just use that link once the slides are posted as well. I believe they're probably also on the Bay Program's website, but I'm not sure where to find them on there. Sorry.
Okay, and David, these are for urban stream restorations, right? Or can we apply these to ag?
Yeah, for right now. Yeah, for right now, the protocols, the revisions were approved specifically for urban stream restoration practices. The agriculture work group is currently looking at some of those recommendations and possibly forming their own group to evaluate the applicability of the protocols for ag settings. As of now, I think you can still use the original expert panel recommendations for agriculture BMPs in the meantime. I should also mention, sorry, there's one other thing I should have mentioned up front. There is a ramp up period for these recommendations. So they are out now, at least for Protocol 1, but they don't fully take effect until July of 2021. So that gives folks time to adjust their contracts, adjust their calculations, get themselves set up for it. So I should have mentioned that up front. But.
And I'm going to talk about the urban versus ag bit in a minute when I show you how it works in CAST. David, do you want to review how you measure bulk density?
Yeah, so I won't go into the specifics. I will say that there's details in the Protocol 1 report on bulk density measurements. But basically the recommendation is that generally you should take samples every 200 to 500 feet along the project reach, and you should have a sample taken from each soil horizon present within the reach just to give you a representative sample. And then there's some guidance there in terms of how to actually collect the specific samples and get them assessed in the lab based on some NRCS recommendations. So I'll say that to kind of keep it brief.
Okay, and then there was a question about measuring TN and TP, and those are standard tests that you send out to a lab. I don't know if you have anything to add to that.
Yes, that's correct. And they do recommend, the panel did recommend some specific laboratory methods and collection methods for those as well to try to keep things as standardized as possible, because the method you use can affect the measurement a little bit.
Yeah, okay. So when you're in CAST and you're editing your scenario and we want to go in and add this, you just go ahead and click on this and you can select what you're doing. In this example is in Montgomery County. Like we do with all of our BMPs and all of our scenarios, we make our selections for the agency, and then we'll select stream restoration here. And it defaults to just the standard urban stream restoration. So we do separate it by urban versus non-urban, but I will tell you that it is affecting the stream bed and bank load. In CAST, in the watershed model, we do not know what portion of land is draining to that stream. We don't know if it's agricultural or urban or a mix or what that mix looks like. So we treat it the same. So you can pick urban and you can pick non-urban, but it gets calculated identically. So the point of picking one versus the other is just to show the state or anyone else who, in your scenario that you are doing it on one versus the other, but it makes no difference in the actual load. So I'm going to pick urban because that's what the information that David went over is really geared toward, because ag has not come up with their own approach, and it could be different for ag, but they've not determined that yet. So I'm going to go ahead and pick urban stream restoration. And if I do that, I can just enter my default for the feet and be done with it, and I'll show you what those default rates are. And that's a great approach for planning purposes. You know you're going to do some stream restoration, but you don't know exactly what that's going to look like, and you want to get a general sense of it. So you put in just the feet that you intend to do, knowing that you can come back and revise it and get more specific when you actually get to doing this project. So for the Chesapeake Bay TMDL, when the states put together their watershed implementation plans, the phase 3 version of their WIPs, they generally used this default value for urban stream restoration and also for non-urban stream restoration. Now there is discussion about whether that is going to, the default will remain, and for urban, David, correct me if I'm wrong, but for urban, that's likely to go away. For agriculture, it may get revised, but the intention is to keep a default for agriculture, simply because NRCS data doesn't include the specifics you would need to do the protocol 1, 2, or 3 calculations. So if I go ahead and revise this and I pick the urban stream restoration protocol, then I still have to enter my feet, and using David's example, it was 1,000 feet, but subtracting off the 100 because it was riprap next to that sewer line, I'll put in that it's 900 feet, and moving this up on my screen. For protocol 1, it was 40.5 was calculated, but doing the 50% efficiency to be conservative, we're putting in 20.25. That was nitrogen. Now we're going to put in our phosphorus, same thing, 68.9, and this is pounds per year. So it's total pounds per year. And then David had calculated 81 tons, which would be 162,000 pounds, but we're taking that 50% reduction, which makes it an easy 81,000 pounds. So if you calculate in tons, just note here that this is pounds. If you had done some of the other protocols in your project, you could also add them in here. David's example was just the prevented sediment, but you could add in others if you had done some denitrification or floodplain reconnection. So if it had those other components, you could add it in. I'm going to just click add, and then that BMP shows up in my scenario. So that's already added. And what I'm going to do is go back to my scenario list, and I've edited that scenario, and I'm going to run it. And then when I want to go see the results, I'm going to go under results. Let me make this a little bigger on the screen. I'm going to go under results, reports, and I can select my report type. And I'm going to want to look at a loads report. And I give my report a name, select my geographic scale, and I'm going to select Montgomery County. It's a lot of counties in the watershed, and there are a couple that are named Montgomery. So I select that, and then I can select my scenario here, and that was called Cabin John. So I will type in Cabin John. I think it was this one, and I can aggregate this, and I can look at major sources, minor sources. I want to look at the specific source, so I can look just at stream bed and bank and not see that lumped in with the forest and wetlands. So I generated that report. I should get an email telling me I've received when that report is completed. I will now want to go and download that report. And here's my idiot button. I just click on repeatedly until it shows up. It helps me become more patient. And then I click download and open up that report. So let's go over this a little bit so you can see how it works. So this is the README on the page that tells me what's in my loads report. This was the scenario that I did, it and has details in here about the name of the scenario and some other information. And then I get all the data on the loads in this report. So we put this in on stream bed and bank, so I want to skip over agriculture. I don't want to see that. I don't want to see developed septic or wastewater. I really want to see what happened in natural, and I'm going to look at that natural category. And I see that there are a number of items here, but the one I'm interested in is stream bed and bank. That's measured in miles. Our report tells us the amount that there's 634.6 miles in this watershed in Cabin John. I'm sorry, I did the whole county in the county. And then I can see my nitrogen load edge of stream, and that's defined on the README. And I can see the pounds here for nitrogen, phosphorus, and sediment. So that tells me what the load is. What I'm probably going to want to do is also download a report that includes my baseline as well as my scenario. So this one had those BMPs in it. I'm going to want to look for the report that had my baseline. And when I download both of those, I can compare the difference in loads and see what the reduction is, if you just want to know what the pounds reduction are from that. And the reason the pounds reduction is going to be different than what I entered, than that 20.25 pounds of nitrogen, is because we do have the delivery factors. So let me talk a little bit about the delivery factors and how these calculations work. If I go to the home page, I can click on source data and download source data. I did that before the webinar, just so it would be speedy. And in the source data table, I've got a list of the definitions of all the load sources. So stream, bed, and bank will be down here. And you'll probably want to take a look at that and read that definition. And I've got the BMP definitions. But way over in this last tab, there's tons of information, are the delivery factors. Now, we've done webinars that have talked about the delivery factors in the past, but we've got that in here, and I want to show you what it looks like for stream, bed, and bank, because this comes up quite a bit. Now, the old expert panel report used the term stream delivery ratio. We don't use the term ratio, we just use the term factor. So the streams don't have a land to water factor. That's what this is up here. They don't have a land to water factor. So that's going to be blank for all of your load sources for streams. What it does have is a stream to river factor, and then that's for nitrogen, phosphorus, and sediment. And it does vary depending on whether it is nitrogen, phosphorus, or sediment. And then we have the river to bay factor. So if you wanted to calculate this outside of CAST, or if you want to replicate what CAST is doing, you would multiply your stream load by for nitrogen this factor and then this factor. So you would multiply by both to get what is delivered to the bay for your particular modeling segment. And we have some other information in here with the geographic references that shows us what those segments are. But again, there are three factors, and what CAST is doing under the hood is multiplying by your stream to river and river to bay. Let me pause here and look at the questions for a minute. I see that there's a question about stream restoration benefits being independent of off-channel work. I'm going to go over how the information, the BMPs that happen upstream, upslope, affect the load that goes to the stream. So when you're doing, the way the whole model works is it takes the average load times the change in inputs times the sensitivity, taking into account the acres and the BMPs and those land to water factors, which you saw were null for the stream load. That's in direct loads, like your stream load, like wastewater treatment plant loads. And then you calculate the stream, bed, and bank load, which I tend to abbreviate STB. So it takes into account all the BMPs up here. So if you're in an agricultural area and you've got cover crops and a nutrient management plan and no-till, all of that is being considered in what gets into that stream, bed, and bank load. And then you calculate, then what CAST does is it calculates the stream restoration BMP reduction from that load that takes into account your no-till nutrient management and cover crops. And then we use those two delivery factors, stream delivery and river delivery. So that's kind of happening all under the hood. And to use CAST, you don't need to know it, but I like to explain it to people so that they're clear on what is happening. So just to reiterate, most BMPs do have an impact on the stream, bed, and bank load. It's not just stream restoration, but stream restoration is the one that directly influences that load. But but your load will change even without stream restoration if you changed your BMPs in the upland areas. This is what's used now, is that, or what we call the default. If you're doing a plan and you don't know what protocol you're going to be using, you don't know exactly how you're going to do that stream restoration, the reduction factor is 0.075 for nitrogen, 0.068 for phosphorus, and 248 pounds per foot. So these are the pounds per foot for stream restoration. When you're using protocol 1, it's just whatever the pounds are that you've entered. Denitrification is, as the name indicates, just for nitrogen. And then floodplain reconnection has nitrogen, phosphorus, and sediment. And so you could do a project that is going to have all three of these nitrogen factors depending on how it's designed. This is the calculation. This is in the CAST documentation, but this is the calculation that's used. And I'm going to, this webinar is being recorded and these slides will be available, so you're going to have this information, but it does have the delivery factors that are multiplied by this in the source data file, so you can use that information if you wanted to calculate this outside of CAST. That's one of the most common questions I get is, what if I want to calculate it outside of CAST? Then this is how you would do that calculation. So the stream load is independent of a sector. So we're looking at the load that comes through natural areas, and a stream is always classified as natural. We're not looking at an urban versus an agricultural load. That's another question that comes up quite a bit on these. Let me pause here and go back to these questions. I see a number have come in. One of them is if stream restoration benefits are independent of the work being done off channel. So if you've got several practices on a site, you want to put in that you've done your stream restoration. If you've also put in some other BMPs, you do want to add those to your scenario as well. So you do want to add the independent BMPs. So if you're doing, for agriculture, an example would be if you're doing riparian fencing along with your buffer, then you would want to put that in, that your cows are no longer in the stream and they are being, fenced out, and you've got a buffer or something. You want to put that in there. So that takes into account that a lot of these projects include several practices. When you're reporting the protocol, Stephanie has asked, when you're adding the BMP and you want to add, if I go back into this scenario, you can always add BMPs using these tabs, and you would go to the natural tab. You can also upload a file. So our more advanced users will upload files. And when you do that, you can certainly add the protocols in a batch upload in this land BMP file. And if you're having trouble with that, then you can let me know and I'll give you an example file that has a protocol BMP in it. But that can certainly be done. Let me pause here and see if there are other questions for David or myself. We have about 5 more minutes. I know we've rushed through this because there's so much to convey, but let me see if there are any other questions. David, did you have anything that you wanted to go ahead and add?
No, I think, like I said, just be on the lookout for the reports. It's tough to cover all of this information in a quick and simple way. So I do encourage folks to go and take a look at the slides and download the different reports. And if you have any questions at that point, you can always feel free to email me. My email address is in the title slide of my presentation. All
right. So when we do have questions, you can, of course, contact David or myself. And if you do contact us, the Bay Program will get that email and we'll be able to respond. This webinar will be posted under Learning, and it will be under the free training videos. So you can see that we've got this video posted for today, and we will put this stream restoration video up here under free training videos once I finish, editing the recording and getting that ready for posting. I will also post a link to the slides because I think those clickable links will be really useful for folks. So that's where you can look for that. And Then other CAST news, we are planning a release to the updated version of CAST, and I think that will be at the end of May, but I am waiting for the Bay Program partnership to make a decision. So anyone who's a CAST user who has a login will be getting an email letting them know what updates are coming to CAST. But you can always go and look for your updates under upgrade history and see what the changes have been to CAST. So anything else, David?
No, just thanks for hosting and having me. I really appreciate it. Hopefully it was helpful for folks.
Okay. Great. Thank you so much, everybody.